This one you don't need to know the details for exactly. It is showing a kind of complicated cyclic process that happens, but I don't need you to know that one. I'm gonna go in order. This one is showing how balance is created, homeostasis, as far as glucose levels go. So if it is too high or too low, there's an imbalance. So this is showing that if it's too high, the pancreas is going to release insulin. That insulin is going to tell the liver to take the glucose that's inside the bloodstream and turn it into glycogen, and it gets stored into the liver. It's also going to be taken up by the cells, because what insulin does is it makes it so that the body doesn't use anything other than glucose in order to get rid of it and get it out of the bloodstream. So pancreas release insulin, the glucose is used up, and that causes the blood sugar to go back to a normal level. Sometimes it can go too low, so that's what this is showing on this side of this balance. So if it is too low, then the pancreas releases glucagon instead of insulin. So too high, it releases insulin, too low, it releases glucagon. And then glucagon is going to tell the liver to go the other way. So take glycogen and make glucose out of it, and then that brings the blood glucose level back up to normal. So I hope that helps with that one. Let's see what else we have here. So this is showing action potential of contractile cardiac muscles. So all of this is showing is the membrane potential and how that changes. So that's going to be the details of that, and like the millivolts that are required for all of that is in a video that I posted. But this is just showing that tension rising and then falling. And then there's a refractory period that happens in here where the muscles can't receive another message to contract until it reaches where it's outside of this absolute refractory period. This just means it can't receive another signal. So it has to get out of this dark blue to at least here before it can get another message to contract. So that is that one. And then this guy is showing pacemakers. So same kind of scenario over here with the millivolts. We're going to start out at -70 or below, or a little bit above as it's showing here. Over here on the side has like the step-by-step. So it's showing that the pacemaker is going to start off the process, and that is going to depolarize and then repolarize. Sometimes there's a little bit of hyperpolarization if it drops down over here. Looks like the cardiac muscles are not showing that here. So depolarization, which means it's not polarized, so it goes back to 0, and then it repolarizes so that the muscle can receive the signal again, and it goes back up and down. But this is the threshold, -40, I think -55 for our skeletal muscles, but it looks like -40 over here for your cardiac is going to be the spot where it's going to continue that action potential until it reaches the very, very top, completely depolarized, and then it's going to start to flow back down. I hope that this helps.